All right, so our first gas law, Boyle's law. So this is Chemistry B, lesson 1.03. So we're going to talk about Boyle's law so that you understand the relationship between volume and pressure. All right, so you will know you've got this down when you can do Boyle's law calculations. All right, so if math isn't your strong suit, I highly recommend focusing in really closely. And we'll do some more practice with these in class too. And you'll also know you got it when you can do things in a more qualitative way and just kind of describe what's going on with pressure and volume as something changes. So, Boyle's law means that pressure is inversely proportional to volume when temperature is held constant. All right, definitely recommend writing that down. But the key is Boyle's law relates pressure and volume. All right, so Boyle's law, the equation looks like this. So your first pressure times your first volume, all right, so this is P1 times V1. So initial pressure, initial volume, will equal your new pressure times your new volume. All right, if you read through the book, you're also going to see this. And what that's telling you is that your pressure times volume at any given moment is going to be a constant value. All right, so if you change something, the other one has to change to keep this constant the same. So let's zone in on this part here. It's inversely proportional. So what that means is this is what a graph of changes in pressure and volume would look like. All right, so you can see that when volume is really high, your pressure, all right, is really low. All right, so a volume of 1,200 milliliters only has a pressure of 1. Whereas if your pressure is really high, all right, then your volume is really low. All right, so they're inverse, they are opposite. Whatever you do to one, the opposite will occur to the other. So if you double your pressure, your volume will decrease in half. If you take your volume and cut it into 3, your pressure is going to multiply by 3. All right? So opposite, whatever you do to one, the opposite will occur to the other. That's what an inverse relationship is. All right. So let's apply that to this. If you squeeze a balloon, what happens to the volume and the pressure? All right, we're going to assume everything else is staying the same. We're just going to focus in on what happens with volume and pressure. All right, so if you take your balloon, all right, and you squeeze it, all right, your volume is going to go down. But because of that inverse relationship, your pressure has to go up. Okay? So here's what Boyle's law looks like in a more quantitative math type way. All right, so this is going to be those word problems. You got to kind of dig things apart in here, figure out what you know, what is being asked for, and then choose an equation to use. So a balloon has a volume of 340 milliliters. So there's my volume at 1.5 atm, or atmospheres. This is why you want to remember what those units stand for. That's going to be our pressure. All right, and this is also going to be our initial volume and our initial pressure. Then it says, what will the volume of the balloon be at standard pressure? So this one's really tricky here. So my V2, I don't know what that is. That's what the question it's saying. What will the volume be? All right. Standard pressure, however, I do know what that would be. That's going to be 1 atmosphere. All right. So that's my P2. So now I'm going to plug that into my Boyle's law. All right. So I have P1 times V1 equals P2 times V2. So I'm going to plug in 1.5 times 340, and that's going to be equal to 1 times my V2. Just going to leave that in there. If it makes you feel more comfortable to make that an X, just because you're used to solving for X in math class, go for it. I like to just leave what value I'm actually multiplying by. So I'm going to simplify this. 340 times 1.5 is 510, which is equal to 1 times my volume. I'm going to divide both sides by 1, and 510 divided by 1 is 1. Alright, one way you can make sure you did this right, my pressure, alright, from my pressure went down, so my volume should go up, and it did. It went from 340 to 510, so that's a sign I did this right. So here's one more. I want you to try this one first. So pause the video, see if you can get it set up right. All right, so a pump contains 0.5 liters of air. You draw back on the pump, expanding the volume until the pressure reads 136.5 kPa. What's the new volume? All right, so V2, that's my question mark. So I've got my equation, P1V1 equals P2V2. I'm going to plug in 273 times 0.5, and that's going to be 136.5 times V. 273 times 0.5 is 136.5 equals 136.5 times V. I'm going to divide both sides by 136.5. And that gives me a new volume of 1 liter. All right, and one last just kind of practice here, going back to this whole more or less qualitative idea. So you draw back on the piston of a pump and the volume of the air triples. All right, so your volume is going to go up 3 times. Which of these following questions would describe what happens? All right, so think through, decide what you think is the right answer. All right, so far all we know is relationships between pressure and volume, so I'm going to rule out the temperature one. All right. Drawing back on the piston isn't going to release the gas. It's just making our volume go up. It has more space. So I can rule out this one. Number of collisions. If you remember our definition of pressure, that is number of collisions. So which one of these describes what should happen with our pressure? If our volume goes up 3 times, our pressure should go down 3 times, or be 1/3 of what it was. All right, so the number of collisions will be reduced to 1/3.